Hi all, good evening and welcome to another interesting session which is Python library for data science. So saying that, let's see what is the agenda which we have planned today. So we will try to talk about what is Python, the features of Python and the top libraries which are available for us to use as part of a data science. So let's start with our first point. What is Python? Okay, so like most of us know, there are various programming languages already available. And why is Python again being introduced as a programming language? So most of us might know other programming languages like Java, C++, Pascal, Fortran, whatever it is. But why Python again? Let's try to see that particular thing. So if we happen to look back at the history, we have so many programming languages like Java or .NET, C Sharp, all this. But each and every programming language which we have was created for a reason. If you happen to see Java, Java is more an application programming. So what is an application programming? Predominantly, it was created in early 90s, where the need of the hour was to build computer applications to capture the data and to transfer the data to your databases. So the whole intent of Java predominantly lies in application build. But for statisticians, the statisticians are the people who work with large amounts of data. For those people, there was no programming language which can help them to capture the data, which we say consume the data, calibrate the data, analyze the data, or visualize the data. Typically, these are the activities what a statistician does. So they always had to rely upon a programming language which was made for other purpose, which was making things even more complex. So with this gap being identified, a Dutch programmer by name Rossum, okay, Rossum created this programming language called Python. He created this programming language Python with a base programming language as C, and the official launch of this was somewhere in 1991. 2 years after he created, he launched this for the public consumption. So this programming language brings in various benefits, and the reason why he named it as Python, it was basically he got this name inspired by his favorite show, which is the flying circus called Monty Python, and from there he used this word Python. But why Python, and why Python now? When it was created in 89 or 91, why Python is seeing so much of adoption or so much of traction now? When it was created, though it was created for statisticians, at that point of time there was a huge challenge with regard to the computational power. The we know the computers or the hardware which are available in mid 90s, late 90s was very minimal and very expensive, and the availability of the structured data was also very limited, and trying to manage both of this with a costly hardware and limited structured data did not bring the required need for leveraging Python during the days. But mid 2005 2007, when the world started having more and more structured data and the price of computation or the hardware started coming down, that's when people realized that they can leverage Python to bring some meaningful insights. So that's where you see an exponential adaptation for the Python starting 2007 or 8 period onward. But why Python? Let's see what makes Python really a benefit for us. So Python is an open source programming language. What does open source mean? Basically, it does not require any license cost. That is basically you can use it for community purpose or for the commercial purpose. There is no license fee required for Python, which makes the cost of acceptance, cost of maintenance very minimal. The next one is easy to learn. So it is very subjective point. Easy to learn. What is easy for me might not be easy for you, and vice versa. But since the base language of Python is C, and most of the concepts what are in other programming languages like Java or C++ are also leveraged here, that makes learning Python very simple. So it is relatively easy to learn, and especially for the people who know programming languages, it becomes even more easier. Then the one other biggest advantage of Python is large standard libraries, which means with every passing day, Python is getting converted into lesser programming need. What do that mean? So for getting any problem addressed, the way we typically do is we write a code, pass the input, get the output. But in Python, what is happening is the leverage of functions is increasingly getting high, which means you can leverage the functions which are already available, so that your need for writing the code is decreasing with every passing day, making the life of the developer comparatively very simple. And these libraries are the modules what we call is maintained by the company. So your cost of carry of your code, the develop, the design, build, maintain, all these things are done externally. So from a company which is adapting Python, the cost of holding the application which is running on Python will become very minimal. Then Python supports both programming language, which is your procedural programming language, and object oriented programming language. So what is procedural programming language? If you happen to write a simple code to add two numbers, so we have to write three blocks of data. The first block where we happen to initialize the variables, the second block where we compute the values, and the third block is where we actually print, which means we cannot change the order of these blocks, and then we have to follow that procedure, then we get the output. That kind of programming is your procedural programming. So Python supports procedural programming. In addition to procedural programming, Python also supports object oriented programming. So what is object oriented programming? Let's see. So if you see, object oriented is also called as modular programming, where we divide the whole problem into smaller chunks, and then these smaller chunks are solutioned, where we write small codes, and whenever we have to solve a bigger problem, we combine those codes to get the solution for your bigger problem, which indirectly you are increasing the reusability, reducing the complexity. So that kind of programming is your object oriented programming. Technically, you use concepts like polymorphism, or you use concepts like your class. All these things are the ones which helps you to divide the problem into smaller problems, build the solution, and reuse the solution. So given these facts, it makes Python a very interesting programming language to learn. Then if you happen to see this, let's go ahead and see the features which are available with Python, making even more attractive. So simplicity. So the whole concept revolves around to make the things as simple as possible. So if you see from a Python standpoint, it is designed such a way that you think more of the code and less of the syntax. So one of the biggest challenge for the developer is the syntax. So the more complex the syntax, the more complex it becomes for the developer. So they have kept it the syntax to be as simple as possible, and especially when you read the code, it is like the English like code. So you don't have to really worry about the syntax part, making it much simpler. Then if you happen to see the open source concept, so basically you don't have any licensing, and it's a open source, helping you to learn and use both for individual or personal use or at the commercial use. So that is your feature which makes the things even more merrier. Okay. Then if you happen to see the third point, the Python code can be written in one computer and executed in other operating systems. So which means that the portability, if you write a code in a Windows, you don't have to really worry when you are putting the code on a Unix server, Mac server, or a Linux server. That portability is awesome, making the things even more easier for carrying or pushing the code into different OS environments. Then, if you see this, Python allows other code languages, other language code to be incorporated within its code, making it even more powerful. So, if you have any components which are already well established, like in a C or C++ code, you can make those code work with Python, so making it extensible and embeddable. That way, things become easier, and reusability component is the maximum. So wherever you have the maximum reusable, then you get the maximum benefit. Then comes your quotient of interpreted. So as we all know, Python is an interpreter driven language, which means the tasks of CPU and memory management are handled by Python itself, thereby making things which is data intensive as resourceful as possible. So if it is not an interpreter, the regular CPU or the regular computer CPU has to handle this, making things little challenging and more resourceful. Here it is less resource consuming. That's why it is interpreted, or the way Python programming works is as an interpreter. Then we have the huge set of libraries which we are going to see. It has some of the very evident libraries such as Numpy, Matplotlib, scikit-learn, making things really easier. So that way you happen to leverage the functionality, and you can do the things. Okay. Last but not the least is on the object oriented approach, which we did already speak. Basically helps to break down the complex problem into smaller problems and then address the problem to get the solution. So basically these things, the simplicity, open source, the interpretation, and huge availability of libraries, all these things are enabling the higher adoption of Python. So with all these particular things, now let's get into our section, which is the libraries which we use for data science, the predominant libraries. So there are various libraries which we use. What I will do is basically I will try to cover some 10 libraries which we use more often than ever. So if you see pandas is a library which is written to do data manipulation and data analysis. So what is data manipulation? So predominantly you get a data in a raw format, and that data needs to be changed or corrected. So when you need to do that data correction, you need an application or a library which can help you to do that. So if I happen to say it's like your Excel in Python, but more stronger, more powerful, and more flexible than Excel. So in Excel, if you want to change the columns or change the rows, or delete the columns or transpose the things, all of this are something which you do as part of your data analysis. But if you see, Excel has its own limitations. So probably based on the number of rows, number of columns, and the data increases, your maneuverability reduces. All of that is addressed in Python. So if you see, pandas is well suited for many kinds of data. Some of the key takeaways in pandas is the tabular data, which is heterogeneously typed columns. And then if you happen to see, ordered and unordered time series data can be easily managed. Arbitrary matrix data with row and column details, and any other form of statistical data or observational data sets can be easily put onto your Python using the pandas library, and then you can make the things which is very easier. Now, what we will do is we will see how pandas is leveraged as part of our Python programming. So let me go to one of my Python notebooks, which is the Jupyter notebook. I use Jupyter notebook as part of Anaconda. Let me take one of the files which will show us how exactly we do the things. So let me do that. Let me open a small file and show how we use pandas. Okay, so now if I see this particular thing, I am importing pandas and I have a file which is the weather of a given city. Let me show you how the data looks like. So when I read the pandas using my function read CSV, so if you see, this is not available in this folder. So let me put the actual path. Okay, okay, 1 second. Okay, so if you see this is a simple data which is in my Excel file. If I see here, I have this SFO. Let me show that. Okay, so if you see this is my file. I have it in a simple Excel, which is the temperature or the weather data of a given city. Let me open that. Okay, so if you see this is the data. We have some 10-15 records, which is the date, temperature, wind speed, and an event. So using this pandas, we can do various operations. Like if I happen to look at, if I want only to see the columns. So if I say df.columns, it will give me the list of column names, the day, temperature, wind speed, event. All these particular things are listed. If I want to see the columns with has the maximum temperature, I go ahead, do this particular thing where I see the records which has the maximum temperature. If you see the record number 2, this first column is the index column. The first, we had only 4 columns in our Excel sheet. If you see 1, 2, 3, 4, when we saw the data in pandas, it is giving 5 columns. The first column is the index column. Now if you see, the column number 2 and column number 8 are the placeholders where we have the maximum temperature 34 and 34. That's what we get to see here using the pandas approach. If you want to get the statistical input of all the columns which are available in our data frame, which are numeric or integers or float values, if you do the describe function, you see the maximum temperature, sorry, the total number of records which has temperatures is 14, while in the wind speed you have 14. The mean value of the temperature is 29. Standard deviation minimum value 25% quartile, 50% quartile, 75% quartile, and the maximum values. Similarly, if you want to change the index, which means we have a standard index which is 0, 1, 2, 3. If I want to change the index to some other field, I go ahead, see the thing, and I see my value. Now if you see, my index is changed. I get only 4 columns. The first column, the date became my index. And with this being my index, I can go ahead, find any value which is available as part of the index. So if I go ahead and give the location function and give the date, which is 3/1/3/2018, this record just gets picked up. So if you see this record gets picked up. So that way, if you want to reset the index what you had changed, you go ahead, have a function called as reset. Then I see this, the index got reset, and if I print, I got back to the original pandas data frame. So using pandas, we can do lot more activities like data manipulation, data cleansing, data transformation. All of this is a possibility with Panda. So what we just saw is very simple. Okay. The next library which we will go ahead and see, Numpy is also very strong and vast library. It is a library for scientific computing in Python. It provides the high performance multidimensional array objects. So the tools for working here are arrays. If you see here, this is a matrix. If you see, this is a 4 rows and 3 column matrix, right? Row 1, row 2, row 3, row 4, column 1, column 2, column 3. These are the 4 rows, column 3 column matrix. Now for every value you have a unique identity. This is 0, 0, 0, 1, 0, 2, which means the index for this particular thing column is 0, the index for this is 1, index for this is 2. So that way you get the column index as 0, 1 or 2. The row index here is 0th row. Therefore, this is 0, 0, which is A of 0, 0. Here row 0, row 1, row 2, row 3. Therefore, Numpy will allow you to do the matrix calculations relatively easy. So if you have to see some simple Numpy operation, let me show that particular thing. If you see this, let me come below. Now I import my Numpy. I create a simple matrix which is the shape of this is 2, 3, which has 2 rows, 3 columns. So 1, 2, 3 is the first row, 4, 5, 6 is the second row. I used the function in numpy.array, array as a function to create a simple matrix. So using Numpy, you can do so many functions. Let's try to see that particular thing. So let's see how to shape and reshape. Now I have a matrix. I first go ahead and print that matrix and get the shape of it. And then I will go ahead and reshape the matrix. Now, if you see this particular thing, my first matrix was 4 cross 2, which is 2 cross 4, which is basically 2 rows. 1, 2, 3, 4 is the first row. 5, 6, 7, 8 was the second row. Therefore, this is printing. The shape of this is 2 rows, 4 columns. By using one simple command, we can go ahead and reshape this particular thing to 4 cross 2. Let's reshape this. If you see this, we just printed second. We using a function called as reshape. We converted this into 4 rows and 2 columns. We also have a function to repeat. So if you see this, if I want to repeat it at a row level or a column level, we can do it using the function repeat. So if I say A, now I repeated this at the row level. So the 1, 2, which is my row, I have repeated thrice, once, twice, thrice. If I change this value as 1, the repetition will happen at the column level. So if you see this, 1 got repeated, 1 1 1 2 2 2 3 3 3. Basically it got repeated. That way you are trying to do the things in repetition and making the things easier. So Numpy has lot many functions which will help us to do the things. So let's see one other function in Numpy. So if you see this particular thing, we can use the NumPy library with the standard built-in functions like the maximum, the minimum, and if you want to do the summation at the row level or at the column level, we have this. So what I have done, I have a simple array which is created, which is of dimension 2 cross 3. Then I use the maximum function from my Python built-in. I use the minimum function. Then I use the sum function, and then I also use the summing at the row level or at the column level. So if you see, this is my initial matrix with a shape 2 cross 3. If you see the maximum array here, a dot maximum, the minimum value, okay, here I did not give this. Okay, so if you see, the maximum value is 4, the minimum value is 1, the sum of this is 15, and if I want to add it at the column level, I get the addition at the column level, I get at the row level. 357, which is the column summation, 1 plus 2, 2 plus 3, 3 plus 4, which is 357. If I want to add at the row, 1 plus 2 is 3 plus 3 is 6, and 2 plus 3 plus 4 is 9. That's how you get these things. So basically NumPy is one other thing which you happen to do. Okay, so that was with relation to our NumPy. With this, let's get into the other library, which is our matplotlib. So for all our visualization, we use matplotlib library. So what is visualization? Visualization is an approach to represent the large data into a visualized format, right? So for that particular thing, we use our visualization. So NumPy is, Matplotlib is one such library which helps us to do the graphical imaging in 2 dimensions. There are various graphs which are available: the bar graph, the histogram, scatter plot, pie plot, bin plot, area plot. All of these are your result of the library matplotlib. So let's take an example for our matplotlib. So if I see this particular thing, matplotlib by default does not come as an installation. So if it is not available, you'll have to install matplotlib. If it is already installed, you don't have to do this. So if you see this, this is a simple line graph. So I have given the coordinates 1 3, which is for 1 3, for 6 5. So for 6 5, then 3 7, and 5 9. So if I run this, go ahead and run this particular thing, I have imported the matplotlib as plt, and I get this particular graph. Similarly, if I happen to see this, I give a range 1 to 5, x as a range, and then plot this as a derivative. So I give my x values, y values, which are derived. That way I go ahead, if I say print of x, I get all this. If I comment, I don't need my x values and y values, so I can go ahead and get my plot accordingly. So if you see, I have generated a line graph which is in this direction. Now if you see, I have also created a 3 plots in one. Basically, if you see, the green color is one line, the red color or orange color is one other line, and blue color is one other line, again created as part of using the matplotlib library and generating a graph out of that particular thing. Now if you see, Below we have a line graph which is generated as a derivative. The next four graphs are all how we can change our x and y values and get the thing. So if you see this, this is a polynomial graph. And if you come down, a polynomial graph incremental. And let me show where I have my other types of graph. Okay. So if you see this, this is a simple bar graph where I am using the random function and plotting an histogram. So this way you get the details. Now, if you see this particular thing, there is also one other library called as cbar. You can use the numpy and cbar, sorry, matplotlib and cbar against your data which is originated from your python. So if you see this particular thing, you can see the histogram. This is a bar graph what we are seeing here, where I have one graph which is represented in red, one graph which is represented in blue. Similarly, if you want to see a histogram, here we have population of different people, which is my data set, and I'm bucketing that based on the intervals every 10 years. So 0 to 10, 10 to 20. So if you see, this is how this buckets. People between 50 to 60 are the maximum in my data set. If I change the width, the box width will reduce. So if you see this, every time I change the parameters like what I give here, this is the bins, this is what I get. So if you see, the width of the bars change. Previously I had put 0.8, now I reduce it to 0.2. These are the attributes available to control the histogram. Then if you see, this is one other graph which is the scatter plot. So as the definition, it is all about coordinate splashing the data against your x and y coordinates. That is your scatter plot. Then comes your stack plot. If you see, this is a stack plot where you have the area, and within a given day, how exactly you can plot the things. So that is your stack plot. Last but not the least is the pie chart, where we have the pie, where we can divide the whole data into 360 degrees and generate the graph. So that is your matplotlib library. Then if you happen to see the Selenium, so basically, like most of us know, Selenium is an automation software, and Python has a library which works you to automate the web browser. So basically, from your Python you can do automation. It can work with Chrome, work with Internet Explorer, Firefox, or even Safari. So basically, you can use the Selenium library, trigger the activities on your browser, and get the things. So this is also one of the highest used libraries within Python. Then comes your library, which is OpenCV. So what is OpenCV? OpenCV is designed to solve the computer vision problem. So what is a computer vision? Basically making a computer read the data with into your system is your computer vision. So let's see one of the things how computer vision works. So if I go here, okay. So the way to install OpenCV is pip install opencv-python. Now what I have done is I have a simple image which is available, a blockchain image. I will show you how that image is read into Python. So I have this simple code where I import the file, then I print the shape of it, then I show that with the legend. So let me highlight this, let me run this. So if you see this with the legend, with the blockchain, the image just got loaded. This way you can read the image and then do various activities using the OpenCV functionality. So basically we can do object detection as one of the things. So many other things can be done using OpenCV. Now using OpenCV in the object detection, let's see how exactly we can do the face detection. Let me have that once. Okay, so this is the face detection. So I have a photo which has a face of a person. Now I am using the OpenCV algorithm, OpenCV library, and I am loading that photo as the part of this reading. Then I will put a square against the photo. So let me show you that particular thing. So if you see, this is a photo of a person, and within the photo it is identifying the face and highlighting the face with a square. That is how many of the cameras what we do today when we point at a group of people, either we get a square or a circle against the faces. That is the concept of face detection within the image. So a similar logic works on the cameras for your face detection. In addition to this, you can also do the video capturing, and in video capturing you can do various activities. So if I run this particular thing, this will start my video, and it will show you the video capturing what is happening during the video. So let me run this particular thing. So if you see this, this is the video which is available. So if I show my hand, it is doing that, and if I say Q, it will quit the video. So that way, using your OpenCV library, you can do various activities. The next library is SciPy. SciPy is again one other library which is used for scientific computing and technical computing, and it works very well with Matplotlib, the Pandas, SysMPy, which are all the libraries. So for performing machine learning algorithms, we use SciPy. Then if you see the next library which is very heavily used in Python is the scikit-learn. Scikit-learn is very often used for your model building in Python for your machine learning, and it is a library which is also a open source, and it features various classification, regression, clustering algorithms. So this way you can do the things and get the most out of it. Okay, so if you see this particular thing, let's see an example for our use of scikit-learn. So this is an example where we have a model which we built for k-means clustering. So if you see this, I am running the data set where I have a few columns: customer ID, gender, age, annual income, spending score, all of this. Within this data set, I am using my sklearn. So I use the sklearn cluster with k-means, where I get the elbow results, where I can see how many clusters the data has to be divided. I am using the k-means and matplotlib. So if I run this particular thing, I get my graph which is telling me what is the ideal number of clusters for a given data. So using that particular data, so if you see, this is the graph which it got just generated. Now I use that data into my k-means model fitting. It says 5 clusters, and I go ahead and do the model fitting. Here I do the machine learning model. Then I am visualizing the data what we just got. So it is giving us an interesting insight how the spread of the customers based on their income and spending score in couple of lines. So that is on your scikit-learn, which helps you to do some of the complex machine learning approaches or algorithms. Then if you see PySpark is an API, exposes the Spark programming model to Python. So basically you are integrating the Spark and Python using the PySpark. So this is an API driven model or a library which helps you to do things relatively easier. Next is your Django. So what is Django? A Django is a library which helps you to do the Python web framework. So what happens in the Python web framework? Basically to do all your Python things on the web-based application, you use your Django. So a framework which provides a structure and common methods like the life of a web application, making it easier. So you can host various applications on your MVT architecture or MVC architecture and combine or couple that with your Python, making the things simpler. That way, Django is one of the highly used library, and that way you get to do the things easier. The next most used library is TensorFlow. So what is TensorFlow? So as part of your machine learning, many a times you will not be able to solve or address some of the complex data scenarios. So for that you use your deep learning, and TensorFlow is a library which helps you to solve such problems. TensorFlow is a library from Google and it helps you to do computation at scale. So if you see this, let me pick an example where we have used TensorFlow for doing a neural network. The way to install TensorFlow is pip install TensorFlow. So TensorFlow, the latest version is 2.1. So there are various functions which are available in TensorFlow. So what we are doing here is we are using TensorFlow to read a data, identify whether a bank note based on the various parameters what we have, is it a original note or not a original note. So basically parameters of a given node are through various attributes like kurtosis attributes. All of this are available. So I use the encoder function, then I read the data. Then if you see, I have imported the TensorFlow, NumPy, Panda, scikit-learn, all of these libraries whatever we discussed. So I'm using my matplotlib for visualization. TensorFlow, I am using the TensorFlow, the version 1 TensorFlow I'm using. Then I'm using NumPy, Pandas, scikit-learn. All of this we are using, reading the data, analyzing the data. Then we are using the model. So we are saving this model, and I am defining the various neural network concepts which are your layers, what we call as hidden layers. Then we use the model which is the multi-layer perceptron. In this case I get the values for all my models, and then I get my final model which I call, and then I run 100 iterations to find my model accuracy. So if you see this, I just ran this particular thing, or rather I can run it again. Let's see what is the accuracy in my previous run. If you see, my accuracy in previous run was 99%. So let me rerun this particular thing to see if you can improve any accuracy. So here when we are running this, it will start seeing the epoch is the iteration. So I have 100 iterations which I am running. So this model will try to see the things 100 iterations, and then it will say if I supply this model with a new data set, it is able to predict with an accuracy level to around 99%. That's what it says. If you see, my epochs are increasing 23, 24, 25. So I have done 100 iterations. So we'll have to wait for 100 iterations, and usually deep learning is time consuming. So many times that's why I often run this beforehand and keep it ready. But anyway, I showed you this. So this way we happen to use various libraries and get the things. Okay, so these are the various things what we happen to do as part of the Python libraries. So for example, if you want to host a website using Python and you have a web framework to be done to push the updates, you can do that using your Django. Flask is one other library and Django is one other library. So that way you can do the things relatively simpler. Okay. So if you see, we are already at 85th or 86th epoch. Let's give a minute or so. It will complete the 100 epochs and then we get to do the things. Okay. So if you see this, my accuracy almost became 100. So with every run, this was a small data set, so the accuracy can be 100, but otherwise you never try to target it for 100% accuracy. This way we happen to cover the most used libraries in Python for this session. So just to summarize, TensorFlow, then we used Django, we used PySpark, then we checked about scikit-learn, we checked about SciPy, we checked about OpenCV, the Matplotlib, Selenium, then Matplotlib, then we happen to see about Numpy and Panda. So these are the various libraries which we use more than often. Thanks everybody for your time. Take care. Bye. Happy learning.